Instead of getting up to put things in the blue, you should be putting trash in there. I'll collect your scissors in a moment. Nehemiah, can you go put that in our place? Thank you so much. No, oh my God. Excuse me. If you don't have scissors, can you please raise your hand so I can help you out? After you cut them, you should be trying to classify, categorize, sort them. Miss Kennedy. Yeah. No. Okay. After you cut them into 6 strips, you should have them in groups by things that are convection, examples of conduction, and examples of radiation. You have to cut them off into individual strips. Individual strips here. You're cutting them out so that you have 6, I'm so sorry, that look like this. Thank you, Nehemiah. Thank you, Shonda. Thank you, Carrie-Ann. And I see groups. Thank you, Carrie-Ann. Oh, you already got these. You did it. You get supposed to hand them out. I appreciate you. I appreciate that I see a lot of people here remembering what we learned yesterday about the 3 ways that energy moves from molecule to molecule. So you have individual. JBL, you need to be at that table. Yes, like, can you please look here? If I remember. All right, a few things I want to remind you of before I give you a few clues. 1. There you go. Winter packets are due when? Friday. You can surely bring it tomorrow, but it is due on Friday. How many points are they worth?
200.
200. And so if you decide, meh, that's a lot of work, I'm not going to do that, you're going to have lots of points to make up. In order to get the A or the B that some of you guys say that you want, you're going to have to be perfect in projects, quizzes, labs, so that you can make up those points if you don't turn in 200 points. So help yourself do the packets. On Friday, we just started talking about convection on the 21st, and then we had a 2-week break. But now, we're coming back, we're getting used to it. You need to apply your brains because we're having a quiz on Friday on conduction, convection, and radiation. And so that means that if you don't understand, you need to be asking questions, but I'm surely going to be asking you questions to make sure you understand. How can I help you? How can I help you? I know, so I don't know why I asked. Just wait and drink it. Before we get started today, I want to read you a quote that I really, really like. Look, in the beginning of the year when you guys did these ladders and you were telling me what you want to do this year and what you want to do with your life, somebody literally said, I want to get D's and F's. If you just want to be a bum with your life, that is your prerogative. It's your business. I can't do anything about that, and this quote won't apply to you. But if you have a vision for yourself of making money, or being able to live in a nice big house, or being able to be successful or famous, or whatever it is, this is a quote that applies to you that you should be thinking even now in the 7th grade every day. I'm not telling you it's gonna be easy, because it is not easy to work hard or to be somebody who is successful. But I am telling you it will be worth it. Even if this just applies to getting A's this quarter, showing your father and mother an A, that moment I'm sure will be worth it when the option is just to be like putting your head down and talking to somebody. It'll be worth it in the end. If your goal is to feel smart in the end, to prove that you are smart because you are all smart, it'll be worth it in the end to put the work forward instead of just putting your head down every day and being a bump on the log. And so I'm reminding you, put in the work, because in the end, it is worth it. On the 21st, we started talking about convection, and we did that little experiment that I failed, but then we watched a video. In the experiment, I had cold water, we dropped in the hot water. What should have happened to the hot water?
It should have been at the top.
It should have went to the top, and the cold water should have. That is convection. Convection is when heated liquid and gas molecules, they rise because they have less density, and they push down the cold molecules. As I'm saying this, you should be looking at those 6 strips of paper and trying to find the 2 that have to do with convection. The 2 that talk about heat rising and cold being pushed down. If it were not for convection, we wouldn't have hurricanes, tornadoes, so it sounds good, right? Like maybe you don't want it, but we also wouldn't have boiling water, and we wouldn't have ocean currents that help people to get from place to place in the ocean. The inside of our earth wouldn't churn, which is kind of like helpful to us. We wouldn't have hot air balloons, which like make for a pretty life. So there are lots of things we would be missing if it were not for convection. These are not. Yes. Yes. So convection, find the 2 things that talk about heat rising and then put them in the same category. The next one we've been talking about for like a bajillion years. Yep, because I feel like that's how long we've been here. It's conduction. When you took notes yesterday, you read, you cited your evidence, you put things into a graphic organizer. What did you find out about conduction? Carry on.
Conduction has no weight in that.
Conduction has a state of matter. What is it? What is it?
Conduction is
Solid. And is it 2 solids that are super far apart, but they're making each other hot?
no. They're kind of close.
They have to be touching. And so for conduction, if you look right here, my hand is touching a hot pan, I get a 3rd degree burn. My hand is touching metal that is touching fire, then I get a 3rd degree burn again. Like it's 2 things, 2 solids touching one another and heat moving because of it. I like this illustration on the bottom because it shows you one molecule having energy and being heated. And even though solids don't go crazy like gases, solids still vibrate more when they're hot. And so it vibrates, and then it gives its energy to the molecules next to it. And then those start vibrating more, and they give energy to the ones that are next to it. And so conduction works like this. Molecules that are next to one another having more energy, and then giving that some of that energy to the molecules that are next to them. And so, in addition to having convection group, you should also have 2 pictures for conduction, where something is touching another solid something and getting hot. You should have those grouped together. Oh, look at you, genius. The last one is radiation, and we'll talk about that in terms of the sun when we get to photosynthesis and when we start talking about convection currents and things like that, because it warms up the ocean and the wind, air. Radiation uses waves in order to heat things up at a distance. So now you're grouping together things that are warmed up by waves at a distance. I don't know about that. Let me pause and ponder. So you should have all yours grouped. After you do, you're going to turn to that page that we worked on yesterday. Right here, this is an example of it. Nehemiah's on that same page. And you're going to put the paper in the right place. You might have to put them up and down instead of to the side. I'm going to check somebody's. I already checked somebody's. And if they got it right, you're going to glue theirs in, and then they're going to come around and check. If you are not somebody that I made a checker, don't have your body up and out of your chair. Keep your body in its place. Raise your hand so somebody knows to come to you. And then when you're done, you can talk at a level 2. Not to someone around the room, because that's not English. But you can talk to the person next to you at a level 2 with your body in your place. Questions, comments, concerns? Thank you for that comment. Maybe if it's done right, but I don't see that it is. So right now, you're turning to this page, and then you're putting examples of convection under convection. Examples of radiation under radiation. Thank you, Jerian, for going to the right page. Have you turned to the right page? Let me see that. Oh, thank you, thank you, thank you. Put them in the right place. Which one is conduction? Which one is convection? Which is radiation? Convection is hot air rising, so this one is right, but this one is not right. Those are right. So these are both sun from a long way off. That's radiation. You have these grouped together, so these are hot things making something else hot because they're touching. Which is that an example of? Move on. Thank you so much, Sean. I'm coming your way. Please go to somebody else. I already saw yours. I don't see them on the page from yesterday. Convection is hot air rising. And conduction are things touching. So can you put them on the right place on the page? Conduction, convection, and radiation. You can also look at this to see how to spell it right. I need you to put it in the right place under conduction, convection. You're taking this to be little. And you. You're gonna look at somebody's page, and if it's wrong, you're not gonna change it for them. You're gonna say, and move on. Don't say it that loud. But so you're not telling them, you're helping. Actually, I've been more. That is right, but the only one thing I wanna see for you. Oh, you check. Yes. Make my load lighter. You were here as well yesterday. Hey, you. Can you please come here and help him because you have the knowledge? I see you're right. Make sure you explain with your mouth and not with your fingers moving stuff.
I need to know my mistake.
Awesome. There might be another one in that. Yeah, you only get 5 minutes. You don't have to have a fast. Yeah. Come back. Not another hour, no. Okay, for JBL, you're gonna be a checker. You check this situation right here. And then you go check his situations over there. Who gave you glue without checking? Somebody checked yours? Okay, they checked it. Conduction, JBL, and you. It's one thing when solid, tough. Convection is when hot air rises, hot air rises. Radiation. Yes, put them on here in the right place. You actually already have them in the right category, so you just have to. This those go where? Wait a minute, they don't be the right way, because I know You're my favorite student. Every day I see you in the except video. Every day I see you in the hall. Like yesterday, I saw you 6 times, and then when it came to class time, I was like, where was Andrew? I want to write the next for you. Raymond, did somebody check yours, or somebody just handed out good willy nilly? Thank you. You don't know my life. Like that should not be a situation you shouldn't be taking. After you are done, you should put your trash into that blue basket on your table, and then Rain is gonna come around and collect your scissors without stabbing you and without you stabbing her. We can do it, guys.
How you just already, you just started.
Oh, you're not doing nothing.
I ain't trying to do it already. Bang, rain, you know.
It wasn't that.
It's radiation because I am all the sun.
I'm not real. You ain't trying to kill me. You trying to check it. Big Mo, you.
Oh, look at mine. How do you do an example and something?
And I'm sorry that doesn't help you, but you can't read my writing.
She literally just gave you all that.
You are not wrong. Miss Kelly.
Somebody check yours.
I'm trying to assist you today.
Somebody check yours.
You check that one.
You realize I was
You try to look at mine. Oh, you try to look at mine. I like tearing up this room.
I didn't tell people what they got on, but you wasn't really want to write on your first shot.
I got around my first try.
Discombobulated. Did you glue these in?
She literally gave me
Come to school tomorrow. Yesterday.
All right, we have one more minute and then we'll start getting ready for an experiment. Thank you to the people who are in their seats talking at a level 2 instead of being anxious.
Was he here?
Not yesterday. So I have a question. You just gonna let my we dry out like that? I'm gonna sit there like that. You just gonna sit there. Yeah, nobody. You just
Don't write what's on the board. You're supposed to figure that out. Put them in.
Yes, there's more to do that.
Oh, what is that for? What name?
Yeah, we're doing it in class though, so it's not like a big deal.
I thought it was like a.
Girl, we don't have spring break for the longest.
But you know, they just don't make it.
Please receive the testimony of George C. Compton, officer prepared to leave tonight. George City Office.
Not now, we'll do it at the end.
They be so
All right, you
prepared.
have 30 seconds to be back in your seat. I will, before we get started. All right. Hey, Kelly, I'm gonna go this. Ramon, can you give this to Kelly? All right, ladies and gentlemen. So I told you we're gonna do experiments 3, swap, tray, to learn about conduction, convection, and also radiation. To get ready for our conduction experiment, what you're going to do right now, right now, is turn to the next clean page in your notebook. Clean page, notebook. Thank you to the people like Sean and Quincy whose mouths aren't yammering. Thank you to the people like Terrion who are changing in the book. Thank you, Sean. Thank you, Ramon, for having your life together. Thank you, you who's figuring it out. Next clean page.
That's my face.
What you owe me prior to leaving this here room, and you will not leave if you don't have this. are the top 5 things here. It's really easy. This is what we do every single time, Shondell, that we do an experiment. Hey, Ramon, I want to encourage you to rise towards maturity.
You got to dig. You did not want to hear what he just.
I'm going to encourage you towards wisdom. I don't know what you said, and I probably don't want to know, so that's okay.
It's what you were about to say right now. Go ahead, say.
Thank you, my
Can I
dear.
get a pencil?
You owe me the testable question. Here's the tricky thing. I usually write down the testable question for you. I'm not doing that. Y'all are smart. You're maturing. You're getting better at science. You can figure it out. Then you're going to write down your hypothesis for the experiment I'll tell you about, your IV, your DV, and the constants. So we always do this whenever we come up against an experiment because I want you to think methodically about how to solve a problem. The experiment that we're going to do, make the best choice that you can for your life. Hold your life, it's right there. Please write your name on this. That's what you're gonna write on, because it's the class notebook. The experiment that we're going to do for conduction, remember, conduction is when molecules transfer heat because they vibrate and they touch the thing next to them and then that thing starts to vibrate and that thing starts to vibrate too, like they vibrate in a row. You're welcome. I'm very sorry. What we're gonna do is I'm gonna get a beaker, a cup of water, and I'm gonna put it in the microwave for 20 minutes. And then when you guys come in, we're going to put wood, plastic, and metal into the hot water and let them sit there for 5 minutes. We did not, but we did something similar. I'm happy you remember and are bringing your prior knowledge.
Ain't that in our notebook?
Thank you to the people whose volume is down. You're gonna have 3 materials, 3 different materials, and you're gonna put them in the hot water for 5 minutes. After 5 minutes, we're gonna take out, drying.
Oh, wait, don't put that.
You're gonna take the materials out and we're going to measure how far up the material heat travels. And so right here, say that this is a piece of wood. We're gonna put our ruler here and we're gonna say, oh, this is hot right here. We're gonna measure to that. Say that this is our piece of plastic. I want you guys to have a seat. Because I'm being imaginative. You leave me alone. This is going to be my piece of metal. And say that the metal is hot all the way over here. You're going to put your ruler here and measure in centimeters how far up the metal that heat traveled. So you have 3 different materials and you're trying to see how far the heat travels, how well the material conducts heat. And so right now you're writing a testable question that relates to this, Gabby. And then you're writing a hypothesis, an IV. An IV is what I change as the scientist. The DV, what you measure. And then you're going to write down the constants. Remember, constants are things that you have to keep the same for the experiment to be fair. Right now, no one is talking because your brilliant brains can do this on their own without somebody helping you. So you are trying to figure these out by yourself and you owe them to me in order to leave. When you have them, raise your hand, make sure you're at a 1. If you have something to say, raise your hand because I didn't hear that. Quincy first, you were going, your hand was up. I can give you a pen. Ideas what I change. I am the scientist. No matter what, you are the scientist. You are the scientist. If you are struggling with the testable question, I want you to remember in the beginning we had like sentence starters. And they would go, how does blank impact blank? If I change blank, will it affect blank? And so we're dealing with wood, metal, plastic, and we're trying to see how far heat travels. And so maybe you want to use those sentence starters in order to write your testable question. Your hypothesis is just a prediction. In my last class, look, everybody is smart. People just have off days. Somebody told me something about if the ice melts, the water will be cloudier. That has nothing to do with what we're talking about. Please. Your guess should be related to the experiment at hand. So on your paper, you should have a testable question. You should have your hypothesis, the IV, the DV, and the constants. So don't just write those words, actually write them out. I am not giving you a testable question. I do that on all the other days of your life.
So,
It says IV, DV, constant.
I get it.
If you don't understand, I need a specific question so that I know what you're struggling with.
you about, like,
One person is talking. Your hypothesis should have, so please tell me, tomorrow when we put metal, plastic, and wood into hot water, what do you think is gonna happen?
Are we doing this tomorrow?
Yeah, we don't have time for that, I think.
Oh, man,
I know she did not ask that question.
Everybody needs their moment, for sure. Everybody needs their processing time, it's okay. One thing you gotta change. So, to move on from testable question, what are we changing in tomorrow's experiment? I don't want you to say it out loud, I want you to write it down. My bad. And so I'll say one more time, the experiment is that you're gonna come in and you're gonna put metal, plastic, and wood, best decision, into hot water. Your hypothesis, what do you think is going to happen when we put metal, wood, and plastic in there? So we're gonna put metal, plastic, and wood in the hot water, take them out after 5 minutes, and then we're going to measure how far heat traveled, how far we can feel the heat. It's not a perfect experiment, because maybe Nehemiah feels differently than Perion and Quincy. Yeah, you do the first 5. And so we're going to have the 3 materials, and we're measuring how far the heat went. I want one more, because I know you can. Stretch that brain. The DV is what I record at the end. So after we take them out of the hot water, what are we measuring? What are we doing with our lives? What's happening? 31. So I should see those things because I, as bad as you want to leave when the time comes, I know you also want to leave.
you know, I'm curious about the question, what is this supposed to be about?
About the experiment that we're doing tomorrow. However, I'm gonna give one to you and then you'll do the rest of them. Because I know you weren't here when we talked about testable questions.
Can I put this? So we're making our own testable question?
Yes, you are.
How many?
I'm gonna come your way. Please, sorry. Just like knocked you out.
Okay. You know what the testable question is? Like, you know what we did tomorrow?
We all wanna know about when I put them in the hot water. I'm not checking for it.
You know what we're doing tomorrow? Experiment. We do T-chart for material.
You don't have to do T-chart and graph today because we haven't done it yet, so you can't really, set that up. How far?
So what you can say how I'm trying to put it in terms of where 8 pieces were. Oh no. Okay, so how the blank affect the blank? Okay, so I'm gonna give you the testable question. I'm gonna give you my testable question, and then you're just gonna give the rest of the time.
Yeah.
My testable
All the
Stupid.
No. Positivity.
materials.
Yes, write the word test the question and then write what I just said.
Hey, you, make sure yours is done. JBL, I wanna pay attention to what you got to
It's just so like.
Let me say this next time. At the beginning of the line, up here where there's not a lot of gaps, I'm gonna be more clear.